In this video we're going to do some converting back and forth from radians into degrees and degrees into radians. To do this we're going to again rely on our unit fraction. This should remind you of when we were going back and forth between decimal degree and DMS form. This time our unit fraction will be dealing with radians to degrees. If we remember from our last lecture, a complete rotation, or 360 degrees, was equal to 2 pi. So we can use the relationship 2 pi equals 360 degrees for a unit fraction. Well, we can simplify this a bit and just look at pi equaling 180 degrees. All I did was divide both sides by 2. Well, using this unit fraction, I can change a number from degrees into radians or radians into degrees. For example, if my question asks to convert 72 degrees to radians exactly, well, first of all, the word exactly lets you know that you're not going to be reaching for your calculator. What I'll do is I'll multiply that 72 degrees by pi divided by 180 degrees. I know it's pi over 180. Well, it's a little clearer if I turn everything into a fraction. I like doing that, dealing with fractions. Now you can see that the degree in the numerator and the degree in the denominator will reduce out and will be left behind with, well, no units. But that's good because radians are unitless. So if I take this fraction, do my multiplication, I believe I can pull out a factor of 9 from the numerator and the denominator, and that would leave me with 8 pi divided by 20. And then I see another factor of 4 I can divide out, and that leaves me with an answer of 2 pi divided by 5. And that is my exact answer. I'm not going to approximate what pi is equal. I'm going to leave pi in there. Remember, pi is an irrational number, and any time I use 3.14, I'm making an approximation, and you'll get the answer wrong if it asks for the exact answer. You could, however, be asked to convert 72 degrees into radians, but with rounding, and in this case they're asking us round to the nearest hundredths of a radian. You would still use the same unit fraction. Again, we want our degrees to reduce out of the numerator and the denominator, leaving behind radians. But what we'll do this time is use our calculator. To use our calculator, we'll go ahead and type in 72 times, and we're going to use the second button, and then over the caret there's the pi symbol, and that will be the approximation for pi, and then we'll divide that by 180 degrees, and we end up with 1.256637061. Well, the problem asked for this rounded to the nearest hundredths, and so our answer would be 1.26. Does this make sense? I always like to check to make sure my answer makes sense before going on. If I remember pi is equal to 3.14, and if I remember pi divided by 2, or what we also can call 90 degrees, was equal to 1.57 radians, 2 pi over 5 is smaller than pi over 2, so this is good. 1.26 is a little bit smaller than 1.57, so I think this is a reasonable answer. I want to again emphasize, when the problem says exact, that means you can't use your calculator. You need to do these things by hand. You need to leave pi in there, or in the case of the trig functions, it'll be one of our special angles, 30 degrees, 45 degrees, or 60 degrees. Round means you can use your calculator. Approximate pi using your calculator, or go ahead and use your sine, cosine, and tangent buttons. I can also convert from radians into degrees. To do this, I'm going to use the same unit fraction. For example, if I'm asked to convert 2 pi divided by 5 to degrees exactly, again, exactly means don't reach for that calculator, I'm still going to multiply it by that same unit fraction. Except this time, instead of pi divided by 180 degrees, we have 180 degrees divided by pi. And in this case, it's sort of easy to pick that out because you know you want a pi in the numerator to be reduced by a pi in the denominator. But the way I like to think about this is, I know I want degrees at the end of this. I know I want my answer to be equal to something degrees. So that degrees, that 180 degrees, has to be in the numerator. Well, I can reduce a factor of pi from the numerator and the denominator, and then I can also divide out a factor of 5, and I'm left behind with 72 degrees, which is good because that's where we started. This is the same problem we did at the beginning of the class, but now we're doing it the other direction. You can, however, be asked a question like this. Convert 1.26 to degrees, rounding to the nearest degree. And your first look might think, well, I already have degrees because look, there's no pi there. Again, there doesn't have to be a pi when you're talking radians. If there's no degree symbol, that means we're talking about radians. So I'll take my 1.26 and I'll multiply it by that same unit fraction. And this is why I said, rather than trying to reduce pi's out, look for where you want your degrees to be. In this case, I want my degrees to be in my numerator because I want my final answer to be in terms of degrees. So I know I'll take my 1.26, I'll multiply it by 180 degrees divided by pi. And this, because we've said to round, I'll use my calculator. So I'll take 1.26 and I'll multiply that by 180 and then divide that by pi, again, second, and then the caret. And I get something that's approximately equal to 72 degrees, which is again the same answer that we had before. So now we've learned how to convert between degrees and radians, whether it's from radians to degrees or degrees into radians. And again, we've talked about watching out for whether the problem asks for an exact answer or an approximate answer.